Hello guys, hello world, Philippines. This is here, Eternal Voice once again. Okay, so now I will be able to break promise regarding that this September, whole month of September is intended for chemistry, vlogging, and live streams. But I found bored also. Okay, relationship problems, blah blah blah. Okay, and then I come to think that I need to divert my attention to solve um, basic problems of mathematics, especially the conversion. Okay, the conversion, basic mathematics conversion questions. Okay, actually I researched already 10 questions. Okay, and then I tried to measure my my stock knowledge regarding basic mathematics. 10, I got 8 only. So it is 80%, right? 8 divided by 10 times 180%. So I have two mistakes, something like that. So I have to share with you the questions now, and then somewhere along the way I will tell you that those questions I got wrong and those questions I got correct. Okay? Because there are questions there that I did not encounter. Okay, when I was in high school or in college, something like that. I cannot remember. That's why I was wrong. Or and then the other wrong also is that the decimal places only. I forgot to move one place for the decimal point, then the figure is already ready. For example, your the answer is 13.37 and your answer is 1.37, but whole operation is correct. It's only like that because I got mistake. If I am correct for that, I will be adding 9 out of 10. So it should be 90%. But due to my, carelessness in doing the mathematical operation, something like that, because I did not rely with the calculator when I do that one. No, I use the calculator, but during the writing of the figure, I I overlooked something like that. Okay. Okay. Let's start now with question number one. Okay. Question number one. Okay. How can I do this? Question number one. Okay. Question number one. Okay. This is relating to mathematics conversion, but you have to have stock knowledge on a little bit of physics, right? Elementary physics. What I mean by elementary physics, basic physics, like that. Okay. So, okay, the question goes like this. Okay, because I write the questions in a sheet of paper and I have to transfer to the blank sheet in order for us to understand well. I got correct on this during the actual solving problem. What is the weight of 1 gallon of water 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 uh, in the, this is the question. Zoom. I will like this. Question number one. What is the weight of 1 gallon of water in time? So the required is the time. Okay, like this. So time is a unit of force, same as unit of force in Newton. Okay, so we have Newton, we have also the time. Okay, so as far as I could remember, because these are stock knowledge, okay, Newton is equal to kilogram meter per second squared. Okay, and the time will be equal to gram 1 gram centimeter per second squared. So you have to take note the centimeter and the gram for the time, and for the Newton you have to take note the kilogram and the meter, something like that. So now here time, so it could looking at the centimeter, the gram, like this. Okay, but the problem is 1 gallon. Okay, so how can we convert 1 gallon to grams? Because time is in terms of gram centimeter per second squared. Okay, something like that. So let's talking about the force. Okay, now we are asked for the force, which is the time. Okay, okay, but we have the gallon, okay, of water. It's very confusing because we are asked of weight, okay, but then the dime is not a unit of weight. Okay, we are asked of the weight, which is, it could be in English unit or in the metric unit. Okay, could it be in grams or could it be in pound, like this? But in dime, okay, it looks like ironic, right? But in this principle, okay, what comes on your mind when you talk about the weight? You always consider the gravity, okay, the gravity, the gravitational pull of. So you need to employ the standards of acceleration due to gravity. Okay, so what are those acceleration due to gravity? Okay, this is part of the solution already. I'll discuss the basic concept. In order we can solve this problem, we need to recall the basic concept of gravitational pull of energy in the earth, gravitational pull of the earth, okay, something like that, and the acceleration due to gravity, something like that. The word gravity is very important here. Okay, we need to have the metric and the English. The metric unit for acceleration due to gravity is this is acceleration, right? Acceleration due to gravity, meaning refers to gravity, of course. The gravitational pull, okay, downward, something like that. Okay, so that is 9.81 meter per second squared. This is the unit of the acceleration due to gravity. Put that in your brain. Okay. When I was in high school, I memorized this one. That's why until now I'll never forget this acceleration due to gravity thing. Okay. So in terms of English, 32. So still the denominator is second squared, but the numerator was changed only to feet because it is in English unit. So these are the constant of acceleration due to gravity, in which this is very helpful to come up with the answer dyne, D-Y-N-E, even though it's just a weight. Okay? We need to consider the acceleration due to gravity, okay? Because that's the weight in the first place. Or else it would be mass is being asked there. It's weight, right? So we need to consider the acceleration due to gravity or the gravity thing, something like that. Okay? first thing to do for this problem is we need to get the formula of weight. Now, where can we get the formula of weight? So, if you are confused, there's still a formula for that. But in my case, I really forgot. At the time when I solved this problem, I really forgot, sure. Okay? So what I'll try to think, I use the density equals to mass over volume. Okay? Because I forgot the other one. Okay? Because this is only stock knowledge, right? I forgot the other one. There's also a formula in terms of weight for that, sure. And I don't have to derive, okay? Because this discussion is not for derivation. Okay? And we have still 9 more problems to solve, right? Okay? So, during the actual solving of this one, okay, I consider the density is equals to mass over volume. So, density is equals to, solution tayo ha, in fairness, ganun yun. So, okay. Pasensya na because I was bored. I'm alone in the room, okay? And I'm also bored in social media, okay? Honestly, I'm bored with Facebook, I'm bored with Instagram or Twitter. So I want to refresh my mind regarding mathematics, right? Because mathematics is the fundamental tool for engineers, right? Or for engineering courses. You need to refresh that one in combination with, as I told, repeatedly in combination with pure sciences. Without the application of the pure sciences, okay, really, the basic formula, the simplest formula in science, then you can correlate or you can, what do you call this one? You can combine, sorry, actual talaga, combine with the basic mathematics, something like that, okay? So, density is equals to mass over volume. Then I can solve now for the mass. Mass is equals to density times the volume. So we can use the volume. Now, take note, okay, the density of water, the standard density of water at STP, diba? At standard temperature and pressure. We discussed that a long time ago also, right? Or let's say the density of water at its reference, and I forgot what's the reference for this, but I'll just consider the STP because that's standard temperature and pressure, right? Correct me if I'm wrong. So the density of water at standard condition, I forgot what temperature is that, okay? As far as I could remember, that's 20 degrees Celsius at room temperature. I'm not really sure. So that's the basis of the scientists come up with the standard density. It could be 20 degrees Celsius or 25. It will not go beyond 25 because the scientists obtained the 1 gram per ml of density at the number. It is 20 degrees Celsius or 25, but I'm not really sure. As long as it is in that range. I guess it's 20 degrees Celsius, okay? But we are not concerned for that, as long as we already know the standard of the density, which is equal to 1 gram per ml. Okay? Now, 1 gram per ml is the density of water. Okay? Which is represent density as a rho, because when I was in college, density is represented by a rho symbol like this. Diba? But let's use small letter d for, simpler discussion. D is equals to 1 gram per ml. Okay. Now, we have the density 1 gram per ml, which is the most common. Okay. Now, we are asking by the dyne, that is in English unit. So, our density also is expected to be in terms of feet, cubic feet, or something like this. Okay. So, the density, okay. So, the density will be in terms, okay, 60 to 43 pounds per cubic feet for water. Okay. As I told you, it's very important to memorize the basic, because we don't have to research in the Google or textbook or anything. It can save time, especially in examinations. Okay. Especially the examinations is not open book. Okay? You will memorize the basic one. So 62.43 pounds per cubic foot. Or feet, sorry. Now, we have the density already. What's left? The volume, right? The volume. How can we obtain the volume? So let's substitute first. Density per cubic feet. My headache now is the volume. Okay? Volume. But I have 1 gallon of water. Volume. Sometimes you have to analyze, even though that is not specified as a volume, because it's not mentioned, the volume of the water, it's not word for word. You have to understand that it's already a volume because of the unit. You got my point? So that is 1 gallon. Let's do it systematically so that we can understand. Okay. Mass is equals to cubic feet, which is the density of water, okay, at standard condition, okay, in English unit or in English system, times the volume, which is the 1 gallon, okay. Oh my gosh! There is inconsistency of the unit. As I told you earlier in my chemistry discussion, stoichiometric chemical calculations, we need to agree first to the unit in order we can come up to unit. Okay? There is gallon, there's a cubic feet like this, and we know that this cubic feet is volume also. Okay? If this cubic feet is volume also, we need this gallon to be converted to cubic feet. Of course. You understand? Something like that. Okay. Okay. Now, we need to convert. Okay? There are a lot of ways how to. I have no choice like that. It's to convert the gallon to cubic feet, right? You understand? No problem because in this question, it's only 1 gallon. So 1 gallon, 2 cubic feet. And now, both are unit of volume. So it agree with one another. Okay, I'll show you the conversion from gallon to cubic feet. In order you can solve conversion factors directly without taking time or consuming time, well, you need to memorize the basic metric system conversions like this and the English conversion. And the English conversion. Only the basic, right? For example, 100 centimeter is equals to 1 meter, something like that. Okay, though we felt bored because we continuously use that in our engineering subject, especially in engineering mathematics, but we have no choice. We have to adopt one because in the real world of being an engineer, we can always use that, especially if you're assigned in the process engineer or in the laboratory, chemical analyst, in which volume are being expressed there all the time, especially the masses, the mass of the chemicals like this, blah, 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 so on. In the analysis, we have no choice. We need to memorize the basic conversion, okay, like that. Okay, so gallons, in this case, volume, gallons to cubic feet. Okay, I'll show you the conversion for that. Okay, my goodness. Okay, to information to refresh our minds regarding sciences, mathematics. But now, I inserted only this at this moment because I was bored solving chemistry problems. Okay. Like it's too much chemical reactions on my head. Really, combustion, neutralization reaction, hydrolysis reaction, okay, synthesis reaction, polymerization, isomerization, blah blah blah, so on so. Okay. Basic mathematics conversion problems. Okay, questions. Okay. 1 gallon. Okay, my gosh. 2 cubic feet like this. It's very difficult if you have no idea because there's a cubic feet. So what comes on your mind if you need to think of another cubic? You have to think cubic centimeter, cubic meter, okay? Because there's a cubic feet, okay? And then you can come up with a gallon, with a conversion of gallon that is going to in the centimeter or in the meter in terms of cubic also, okay? In my case, since I've already have the knowledge between the liter and the gallons, okay? So I focus on the liters because the liters have also the proportion to cubic centimeter, okay, coming from the meter like that. With that principle equals to 1,000 cubic centimeters. So that's my basis, okay? And then through that centimeter going feet, you can easily convert metric to English system, okay? For this, okay? Actually, there are so many things to do that, but in my case, I let this 1 gallon, 2 liter, then liter, 2 centimeter, then 2 meter, then the cubic feet. So 4 process in a row in this conversion. Again, gallon to liter, liter to centimeter, centimeter to meter, and then to feet. Okay. Carrying the cubic. The word cubic. Gallon to liter, okay, cubic centimeter, okay, cubic meter, and then later on, cubic feet. Since we have now the conversion factors also from centimeter to 1 meter, meter to feet, then bingo, you can solve the cubic feet. Do the mathematical operation, okay, like that. Okay, let's start systematically, okay, in organized fashion. My gosh, ganun talaga. Okay, 1 gallon, English ha, English system tayo po. 1 gallon is equals to 3.785 liters standard. Okay, problems dealing in English system, really, because gallons are only physics and chemistry. Okay, especially in volume. Okay, so 1 gallon is equal to 3.785 liters. Okay, like that. Do the mathematical operation. And go back to, and then later we'll go back to the original equation and substitute it there, cancels out, and then blah blah bingo. Something like that. Okay. 1 gallon. Okay. 3.75 liters. Okay. Like that. Okay, 1 liter is equals to 1,000 cubic centimeter. 1,000 cubic centimeter. Like this, malom. 1,000 cubic centimeter. Now, we need to convert the centimeter to meter so that we can go to the feet, right? So, 1 meter is equal to 100 centimeter, okay, close and open parenthesis, raised to the power 3. Whole quantity to the power of 3, because we have cubic centimeter, in order that this numerator will become also the cubic meter and the cubic centimeter, something like that. Okay? Okay? So in this case, okay, it's reversed. Okay? This is actual solving also. Okay. So it's reversed, something like that. I'll tell you frankly, in mathematics, you have to take note also the placement of the variable, because the placement of the variable is very important. Like this, I got mistake. You should flip up that one. Flip up meaning you have to turn that one upside down so that it will be cancels out. Okay. But then again, it should be detected because it will never be cancelled if it is not in the numerator and in the denominator. Okay, that's why I detected this form. I detected when I review it. Okay, be careful. Okay, like this. Flip that one. Okay, so the 100 centimeter will be down, and the meter will be up. See? 1 meter is equals to 100 centimeter. So in order to cancel the cubic centimeter from the cubic centimeter here, 100 centimeter, multiply it by 3 times. Also multiply that 3 times. Centimeter times centimeter times centimeter is equals to cubic centimeter. This is the way how we discuss. Okay? That's why it becomes cubic centimeter, because the centimeter is multiplied 3 times itself. Again, that's why it becomes cubic centimeter, because the centimeter is multiplied by itself 3 times. It's also 100. And also this 1, also 1 times 1 times 1. And then the meter also, meter times meter times meter. So it could not be cubic meter, since cubic is equal to 3. That is cubic. Okay? Terminology only. Sometimes you use 4, so etc. like this. DC to centim, like that a lot. Okay? And then you should be careful also. Because sometimes the problem will be using only decimeter, like this, and you have to convert that into figure before conversion. Okay? Something like that. Okay? Okay. We need to cancel now, but be sure you cancel it after, multiplying 3 times by itself. Okay? Okay? Centimeter and the liter. So what left is the cubic meter. Okay, now we go to the feet now, because we are concerned now to the cubic feet. Okay? Because in our original equation here, there's a cubic feet in the density. So how can we agree if they will not convert it to cubic feet, right? So that's our purpose, why we go to that conversion further. Okay? Like this. So, again, in basic conversion factor, okay, you should also memorize. Again, the power of memorization is very important. It's only first time, second time, or third time memorizing that one, that it will retain to your brain. Okay? 5 years, 6 years, 8 years, 10 years, 20 years. In my case, 20 years. I still remember because I memorized that when I was in high school. Okay? So, 1 feet is equals to 0.3048 and 8.28 feet. Okay? Like that. It depends on the problem or your convenience, as long as you and it means master or expert, or like that. Or shall we say quick, like that. Okay? So 1 meter is equals to 1 feet, sorry, because we are now on the last portion of the conversion. So 1 feet is equals to 0.3048 meters. Now, you have again to raise to the power of 3 so that it will be cancels out. You need to cancel out your cubic meter in the first place, okay? So raise to the power 3. Okay? Now, 0.3048 raised to the power 3, you need to do that. 0.3048 times 0.3048 3 times by itself, like this. And then 1 also, 1 times 1 times 1 times 1, 3 times. Okay? Now, we can obtain the unit cubic feet. So we are now happy because our density in our equation used having cubic feet. And now we can now have the unit of the force. Okay, later on. My gosh. It's very challenging, really. It's really challenging. When I look at the question before sharing this to you, I enjoy a lot in solving, okay? Because, it's enjoyable, okay? Like that. Okay. Because there are a lot of errors, okay? If you are, if you are careless enough, the decimal points, okay? A while ago, I got wrong for that. That's why I got only 8 out of 10. Oh my gosh. Okay? So, 1,000 times 1,000 times 1,000. Okay. Actually, in the scientific calculator, we can do that in one time. But this is not a scientific calculator. I'm using the ordinary calculator used in the sari-sari store business. Okay? or in simpler mathematics or like that. This is not a scientific calculator. It takes a long time for me to solve. Okay? Like that. 1 equals, oh my gosh! Okay. 1,000 times 3.785. Sorry for that. Okay? If you think that, oh, it's very impossible, why like this? Then you have to review also, That's the technique. Then, why is becoming big? Why like this? Too small, like that. You have to analyze also before going further. Because if you will not analyze also, you will be wrong. If you suspect already, that's very high, it's very low, don't proceed further, right? Something like that. That's why the power of review is very important. Times 1,000. Charot. My gosh. 3. My gosh, I doubt I can finish this. Sorry. I doubt I cannot finish the other problems and we can continue that tomorrow. Okay. 3,785. And then next is the denominator. The numbers in the denominator. So 100 raised to the power 3. We will try 48 times this one. Oh, my gosh. So if you have a number that's very long, can you see? This is the answer after multiplying 3 times by itself, the 0.3048. So there's a lot of numbers. In this manner, you can use the rounding off rule in mathematics. Can you still remember that one? Rule. How to round off. Okay? Something like that. You have to cut it off because so many numbers after the decimal point and it causes a lot of headache. And there's no space enough in your paper during the examination, the problem. Decimal places, okay? And we don't have to be detailed for the rounded off because there's a lot of rule there. We need to round off only based on the actual that we have now, okay? My gosh. This one. Or you cannot round it off this because there's still another number to be multiplied. Okay? It's up to you. Okay? You have your own choice. Times. Oh, you have to put this one first because correct, I'm correct. Okay, this I'll round it off this first because that's another quantity. Okay? Sorry. So 0.0283. I like to until 8 only. 0.283168. Okay? 7th decimal place only. Okay? At least. And then multiplied by 100 times 100 times 100. So 100 multiplied 3 times by itself, count only the 0 and that would be the answer. That is the rule. No need to use the calculator. So it could be 1 million. Count the 0. There are 6 zeros. 6 zeros represent as 1 million, right? Ano? Yeah! Hapit na June. Okay. Times 1 million. Okay. 228,316.846. When you write the numbers, also be careful, because if you only missed one number of that, you will be entirely wrong. Okay? Good only if the question is multiple choice. But if it is not multiple choice, problem. Show your solution, problem for you. Okay? But don't worry, most of the examinations today are multiple choice. Okay? 3785 divided by 28,316.846 is equals to. We have 0.1336. Yes. The answer is 0.13366 cubic feet. And I'm going back to our original formula, and we need to substitute that one there, here. Okay, when you substitute the 0.13666, what is being left is the pound. Okay, oh my goodness, another problem. You know, the author of the problem is really wanted you to analyze and to think it deeply so that you can apply the various conversions. They did not give the direct unit also to come up with a direct answer. That's the problem in most examination. They try to measure the, you know, comprehension ability of the student. Okay. So we have now 62.43. Oh my gosh. Mass. Gusto ko yung mga ganito lang, yung mga ano lang. Ayoko yung mga x squared, whatever. Everything started with the basic equal to 1. Because if you don't understand the basic, how much more in the complicated and difficult one? Okay? So that's why what I did in the board examination, okay, I started with the simpler problems before going to the complicated problems. And then if I have time, I'll go back to the complicated problems. It requires too much time, but only one question. Okay, then others will suffer how many questions. Then you have so many points there. Whereas that one complicated question, very long, but it will take time to 20 minutes for only one answer, and then problem. Okay, it will use up most of your time. Good if you can get the correct answer, but if you cannot get the correct answer, your time will be wasted up. So that's why you will start for the simpler one before going to the complicated one, unless you know how to solve that difficult problem and complicated problem. You can do it. Okay, it's up to you, but this is only advice during taking the examination, something like that. Especially dealing with numbers and problems. Okay, like that. Okay, 62.43 pounds per cubic feet. Ayaw jud mo kahadlok na ang density, ang yung denominator raised to the power of 3. It's just because for the conversion only. Okay? Don't be afraid. Ganon yan. Charot. So, our 1 gallon now will be now 2.133 66 cubic feet. Okay? This is gonna be only for the purpose of discussion, we make it slow and we make it systematic. But, you know, in giving the problem solving, you have the foundation that is gonna be the best thing to do, because it's gonna be like that always, okay? That's why you cannot get the complicated and difficult ones, because you confused the basic ones. Okay, it's all started with the basic one. That's why we have prerequisites before taking up the other subjects in higher class, because that's the purpose. We need to learn the basic concepts first before going to the difficult one. Okay, something like that. So this is our okay, cancel the cubic feet here. Okay, what is left is pound. Okay, our answer is 8.34 pound. Oh my goodness, 8.344769 pound. Because as in English, English unit. Because in metric unit, this is grams supposedly. What is the weight of 1 gallon of water in dime? Now, we have already the weight. We represented as a mass. Now, since this is a mass, due to gravity has not yet been considered. Remember again, if we talk about mass, acceleration due to gravity, or the gravity principle, gravitational pull of the earth downward, has not yet been considered if it is talking about mass. Okay? But if we talk about weight, acceleration due to gravity, and the gravitational pull of downward, force downward, is considered. Okay? So what is the way? So we need to incorporate our acceleration due to gravity constant that I discussed in the introduction of this problem. Okay? Which is here. The 30. Now, okay, so that's still pound. Okay, and you ask for the dyne. Remember, the dyne is a unit of force. And you know the definition of meter per second squared. Now, there's also a headache there. There's a gram. Okay? If there is a gram, and this is a pound, then we need to convert this pound to gravity. You understand? Which is in terms of feet per second squared. Okay, now we convert this pound to gram. It's just because we have the definition of dyne, which is equal to gram per centimeter squared. But, okay, like, or we can simply use the equation by second law of Isaac Newton. Oh my God, sorry, sir. I tried this one in actual because I solved that before a while ago. I did not use the Isaac Newton. Okay, second law of Isaac Newton in physics, the three laws of motion, in which a law of acceleration, right? Law of inertia, law of acceleration, or law of free-falling body. We remember Isaac Newton in physics. Okay, we need to consider the second law. Force is equal to mass times acceleration. Why I do that? Because we need the acceleration, and we need also the force, and we have the mass. And dyne is a force. So this is the more direct formula we can use in order we can determine the dyne. Because the dyne is a force, and we have a basic formula of force, which is equals to force is equals to mass per pound, and we convert it to grams, and we have also the acceleration due to gravity in time. Okay, like that. I did use this formula when I was because I'll just convert. Okay, I must. How many pound in 1 gram? So 1 pound is equal to 454 grams. Okay, again, 1 pound is equal. Okay, I memorized this also when I was in high school. Okay, like, and until now I'll never forget. 1 pound is equal to 454 grams. Okay, this is the conversion. 1 pound is equal to 454 grams. What we got? So we have now the grams, mass in grams. 8.344 769, my gosh, mass 3,780. Employing the second law of Isaac Newton, the three laws of motion, in which force is equal to mass times accelerations. Since the required is dyne, it is a unit of force. So we can compute now for the force, which is a dyne, right? Hello guys. This equals to mass times acceleration. Okay, what is being asked, the gram is there already, then we can compute now. Okay, so mass 3,007. Just substituting, simple substitution already. Plug in to the formula. 788.53 grams. That's the acceleration due to gravity. Okay, acceleration due to gravity, we have the 9.81. We should choose. Now, this is also the confusing thing because a while ago, okay, we call this as a challenge question. Okay, number 10. This is the number 10, but I made this as number 1 in order to purpose only for the discussion, right? Okay, second squared because your mass is grams, so you have to correlate with that to the metric unit, which is equal to 9.81 meter per second squared, and put that there. Okay. Too much problem. 9.81 grams meter per second squared. 1 grams meter per second squared. Okay. Take that note. Acceleration grams per meter second squared. Okay, like that. Okay? And then we can get the time for this in terms of centimeter squared, gram centimeter per second squared. Okay? Like that. Multiply this one. Since we have the meter in this 9.8 centimeter squared. Okay? So you are not yet done. Even though you substitute to the acceleration, you still have to do it like this. Okay? Like that. Okay. The meter is 1 meter is equals to 100 centimeter. 100 centimeter. Sorry. 1 meter, 100 centimeter. Like this. Meter is equals to 100 centimeter. And then we need to cancel the meter. Okay. 100 centimeter equals to 1 meter. The numerator will be on, of course, on the top. My gosh, what's happening? 1 meter. And the denominator is meter. So what's left is centimeter. Okay. Gosh. So we have now the answer. Remember, it's dirty also. Really, it's not clean. Sometimes you have also to make your paper clean during the solution. Okay, it has a factor why your score will be lower also, because you'll be confused somewhere along the way if your solution is very dirty. Just like this, very dirty also. You do the calculation, you need to make it clean in order for you to see it clearly. But this is only minor thing, huh? But for me, it's very necessary so that you can see clearly and you will not be confused. You will not miss anything, the unit, like that. Okay? Because what pressured us in the examination is time. Okay? That in one examination, something like that. So we are pressured. So sometimes our, very dirty, really. That you can erase and sometimes it will become dirty, really. Okay? So in this case, okay, due to my, in hurry, I put grams on the acceleration due to gravity, but this in my mind it is in the dyne. There's no gram in the acceleration due to gravity, as you can see with my, in a clerical error, and then when I reviewed it, I'll corrected it, something like that. So that's why it's very important, the power of review. Okay, in anything. Okay. Like centimeter per second squared is equals to 1 dyne, which is the unit of the force. But look at this. Most students, including me, charot, really, they will be confused because the question is not asking for the force. Especially when they forgot what is dyne all about. You understand? Now, an effort that much, though you are not intelligent, you're just only average, something like, if you studied a lot and prepared a lot, that the dyne is a unit of force, but if you don't know the dyne, that this is the unit of force, then you'll be lost. Okay, because usually the problem will ask only for Newton, Newton, from joules to Newton, like that, convert it, okay, to kilogram, meter per second squared. For the Newton. But this is the dyne thing. This is rare and unusual case because most of the problems use Newton, especially in the problems that required force. Okay, why I do that? Because in our basic concept, energy is the capacity to do work. Our energy now will become the work. So, energy is equal to force times distance because the work is also force times distance, equilibrium. Though this is a chemistry equilibrium, but in terms of the derivation of the formula, since you know that work is the energy is the capacity to do work, then automatically work is equals to energy. Then energy is equals to force times distance, or work is equals to force times distance. Now the problem is giving to you is energy. Okay, it's giving you the joules, and joules is the unit of energy. Okay. Joules is the unit of energy. It is not interpreted as the unit of work in the basic concept. That's why the students will be confused for that. Okay? And there's no such basic formula that the instructor will directly give energy is equals to force times distance. No, it's not like that. It's not mentioned in the book. Okay? We derive that only. I derive it personally because I know that concept is equal. Okay, like that. And I will remind you, if you'll talk board examination, think that there are formulas that you will connect by the other formulas in order you can solve for another formula and professor. That's the technique. Okay? Sure, that is the technique. And that is a great advantage in order for you to pass a company examination, a government examination, or whatever examination is that. Okay? If you have the basic concept, derive your own formula because there's a lot of formulas used, right? And then sometimes the instructors will not equate this formula to our only, like this chemistry, 2 hours only. Another class will follow like that. Do you think he can explain to you all? No, they cannot. No. Why I'm doing Sorbonne, my gosh. Yes, really, because I can relate this when I was in college, really. I found really difficult to survive, and I struggled a lot. Really, I cried, of course. I did it, I cried. Because it's very difficult, really. It's really, very difficult, especially in the major of chemical engineering. Too much, okay? You cannot see things and chemical reactions very difficult and your professor because they are not 100% efficient to discuss to you the major of that lesson. Sometimes they can only discuss 3/4, okay, 1/2, something like that, but not the entire lesson. Maybe, but they will do it roughly. Roughly, okay? Like that. That's why also I want really to be in the future to be a professor also someday. We don't know, okay? Because I want to share my knowledge also to our young minds of our students that teaching is not gonna be like that. It should be systematized and organized so that to the students. Because how can we mold the young minds of the students if we will not discuss it in a systematized and in organized fashion? Something like that. They will be confused. Okay, something like that. But I'm not speaking to all. There's some or a lot also doing good in a discussion. I'm just telling you, in college, especially magna cum laude, summa cum laude, or whatever, level of understanding with them. No, it's not like that, really. Okay, if you are an instructor, a professor, or any doctorate, master's or whatever, you have to adjust your level because you are dealing with the students, and the minds of the students is not the same as you. Okay, so you need to, or they extracted already from their minds the basic concepts. Okay, because even though how difficult is that, they can still do that. Though it's not perfect, but at least they can somewhere closer to get the correct answer. Okay, then bingo, something like that. Then it's a great advantage. Okay, like that. Okay. I tell you frankly, I'm not intelligent, okay? But when I'm honest, even though I'm not intelligent, that's my goal. That's why I passed only, I'm not failing, because my goal is very high. Because if I'm only aiming to pass, maybe I will fail. So you should aim high in order for you to pass, okay? Aim high in order for you to pass. Do not just aim to pass because more or less you will fail. Something like that. Okay? That's a motivation for everybody who wish to take different kinds of examinations in your entire life. May ganun talaga. Because if you just aim to pass like that. We are now in the... Anyway, tomorrow we can still sleep, right? Okay. Sorry for that. I'm really, really bored, okay? Because it's not my inclination, really. I was a kid, growing up. It's not my inclination to... I watch movies, but I'm not really that into it or hooked into it, okay? So, that's why I'm into only singing, reading, like this, research, like this. A family-oriented person, like this. And I am not an outgoing person also. Okay? So 3,788. Do the math na tayo, ha? Malingaw, dyan ko anin. Fairness. Diba? I will share to you. I do the exercise and work out, right? I exercise physically. Then, you should also exercise mentally. So this is an example of exercising your brain mentally, right? So I do the exercise physically, and I do the exercise mentally, and then I also do the exercise spiritually. Okay, every day I'll pray to God, okay? And then I also do for singing. So meaning to say, I balance myself just like a chemical reaction. Oh my gosh. So everything, the world, everything is to be balanced, positive. So there will be no more negative. So what will happen? So it's also not good, right? So if all are negatives, it's also bad. So that's where there's a balance. You should have check and balance, something like that. Okay? There's no such perfection. That's the thing there. There's no such perfection. Something like you have to balance anything. Something like this. Okay? Do not overdo something and then you just focus on that, because it's also not good to, you will be stressed. So it's not also good. If I do problem solving from the morning until the night, so what's that? It's abnormal already, right? So you should vary your activities, okay? Like that. I also do singing all the time. It's also abnormal. Like that. But sometimes, admittedly, I'll do singing too much. Okay? But at least I have, the variation. Okay? Like 7, 8, 8. Siguro kung nagmaestro ko, dugay sa kay mahuman. Oh. Oh Lord God. My answer is raised to the power 6. We do this like this, something, because too much writing, right? It's also like this sometimes in mathematics. So you have to count only the count 1, 2, 3, 4, 5, 6. So 3.72 times 10 to the... Our answer, is, look at the paper. Problem here, this one. Okay. What is the weight of 1 gallon of water in time? The answer is 3.72 times 10 to the 6. Okay? Time, or gram, centimeter, second squared is just the same. Okay? So I already did the most difficult problem, and the 9 problems are already conversion, blah, 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 so on. So it's easy now tomorrow. Oh my gosh. Okay. So I advise you tomorrow, we need to recall the basic, conversion factors, the acceleration due to the gravity, okay, the density of water, okay, the specific gravity of the substance, okay, remember that one? And then the formula of volume, relationship to density, mass, volume, and the relationship to force, work, and law of inertia, law of acceleration, free-falling body, something like that, okay? And also, you need to remember also, I told you before, right, that we have the energy is equals to force times distance, because it is work is equals to force times distance. Then we can equate that also to the another formula by Albert Einstein, the theory of relativity, okay? E is equals to mc squared, where m is equals to the mass of an object in motion, of course, because it is paired with a velocity or speed, and times the small letter c, which is the speed of light, okay? Speed of light at a vacuum. Oh my gosh, it goes deeper, right? Okay, E is equals to mc squared, m is the mass of the object in motion, times c, which is the velocity or the speed, okay, raised to the power 3 times 10 meter per second. 3 times 10 to the 8 meter per second. Okay. So, what is the speed of light? So, the answer will be 3 times 10 raised to the power 8 meter per second at a vacuum by Albert Einstein, the theory of relativity. Okay, now I will equate that to the E is equals to force times distance, and then after that I can get another formula also for the force, for the mass, for the velocity. Okay, so in this problem you can add also velocity like this, and the students will be confused already when there's a velocity and then because there's a relationship, there's a correlation, something like that. Okay, especially if this having an object like this, somebody throw an object there in the gallon of water. My gosh, something like that, because it's in motion. Okay, okay, like that. But that theory of relativity is not used most of the times, right? It's only the speed of light. Okay, 3 times 10. Okay, 3 times 10 to the power 8. Okay, 3 times 10 to the power 8. How much that in figure? 8 zeros, how much? Muna siya ang ikuskun sa light in a vacuum. So, kung 8 zeros, so ano siya? 3, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So, 2, oh my God, 300 million? Do it by yourself. Maybe I was wrong. Okay, 300 million meter per second, or 3 times 10 to the 8 meter per second is the speed of light at a vacuum by the activity. Okay, because we can also equate that there. Another thing also, energy also. Okay, that's the power of science and mathematics, because there's a lot of relationships, there's a lot of formulas, and you have to connect that one and they come up to a very simpler formula. We have also the formula, right, as I discussed in the ideal gas laws. Okay, the gases problem solving. Okay, E is equals to 3 halves. Okay, the number of moles times the number of moles times the R, the universal gas constant or ideal gas constant, times T in Kelvin. Now equate that all, because that's also energy. Okay, energy 1 is equals to energy 2 is equals to energy 3, and try to cancel out the variable there that is common. What is the new formula of certain variable or that energy, something like that. Okay, just like in ideal gas law, constant 1 is equals to constant 2, and we can come to the Boyle's law, like that. Constant 1 is equals to constant 2, and we come up to the Charles law, something like that. Okay? My gosh. And the Avogadro law. Oh my gosh. And then our basic formula is only the PV in RT, something like that. Okay? And you can base that every time there. Okay, something like, it's just the same here. So those sciences problems are also obtained. We can also use that in the mathematics also. Okay, that's the technique. Okay, I love to solve also mathematics because this is the lowest score in my board exam. Okay, there are 3 days in the board examination, and this is under general engineering. Okay, first day is the general engineering, second day is the physical and chemical sciences, all about science, and the third day are major, the chemical engineering. Okay, to test mathematics, engineering mechanics, strength of materials, probability and statistics, algebra, geometry, advanced engineering mathematics, differential equation, integral calculus, differential calculus, blah, blah, blah. So in that area, my score is very low. And it is really proven, because I tell you a while ago, I'm not good in mathematics. Okay? I confessed that to you. I'm not good in mathematics, so it's really proven after the examination, my scores also in the mathematics area, most of the time, it's also low. And thank God, my highest score is chemical engineering, because I'm taking up chemical engineering on the third day. Okay, and my second top score is the physical and chemical sciences examination in day 2. It was pulled only in day 1. My gosh, really, it is really pulled. A little too much pulled, really. Because if it is not too much pulled, maybe I can reach something a little bit higher. Really. My gosh. because it goes up a little bit to the passing percentage. It goes up, okay? The passing percentage is 70%, but it goes up a little bit, okay? Going to 8, really pulling off. Maybe it will reach to somewhere in the 80%, something like that, okay? At least. But it was very low on the first day. That's why I have no choice. I have to accept the result, okay? My gosh. Charot. Charot lang, okay? But that's reality. Okay, thank you so much minutes to do this live streaming regarding solving basic mathematics problem using conversion factors. Okay, and I want to divert my attention aside from sciences or chemistry. I need to solve for mathematics problem. Okay, like that. Thank you so much. Thank you so much for watching my live streaming. This is again, I am a Ay,